we get to assume that d dx of sine of x is cosine of x. That's usually a proof that you have to do using a special limit. But now we get to say, hey, we already know what the derivative of sine of x is. It's cosine of x. And we know what the derivative of cosine of x is, negative sine of x. So assuming those two things are true, we're supposed to prove that this derivative is equal to this derivative. So it's a proof, which means you're supposed to just take the left side and rework it until it matches the right side. Okay, so the first thing I'm going to do is rewrite tangent in terms of sine and cosine. Tangent is sine of x over cosine of x. Okay, anytime you see tangent, you can always rewrite it in this form. Maybe it won't help, but sometimes it will. And if I'm trying to take a derivative of two functions that are being divided from one another, then I can use the quotient rule. So the derivative means that the derivative using the quotient rule means you take a derivative of sine of x, that makes cosine of x, and then you multiply that times cosine of x. The bottom function kept the same. This is the quotient rule, okay? So I'm just doing the quotient rule. Now I'm going to subtract it by the top function kept the same times the derivative of the bottom function, so that's negative sine of x. That's all over the bottom function squared. Okay, and then the top, cosine times cosine makes cosine squared x. And then negative sine of x times negative sine of x, that makes positive sine squared x. And that's all over cosine x squared. But look, this is a Pythagorean identity. Sine squared plus cosine squared makes 1. Anytime you see sine being squared plus cosine being squared, that makes 1. And we're pretty much done the proof now that we have that fact, because cosine is the reciprocal of secant, right? So instead of saying 1 over cosine, you could say 1 over secant, or in other words, secant squared x. So now we're done the proof.